Now let's talk about why there's this adjustment when you have data from a sample. When you calculate the variance or standard deviation to measure the spread of a sample, the goal is to get a rough idea or to estimate the spread of the entire population. In other words, the purpose of calculating the sample variance or sample standard deviation is to try to get a rough idea of what the population variance or population standard deviation equals. So the sample variance right here is meant to estimate the population variance over here, and the sample standard deviation here is meant to estimate the population standard deviation over here. A sample value estimates the population value, and we see right here that the sample values came out smaller than the population values, and the reason why is because the sample had less dispersion than the entire population. And when you take a sample from the population, this actually tends to happen often. There's actually a tendency for samples to have less spread than the populations they come from. The reason why is because samples don't capture all of the extreme values that are found in the entire population, just like how this sample didn't capture the extreme value of 84. So what this means is that if you don't use any adjustment, your sample variance and sample standard deviation will tend to underestimate the population variance and standard deviation because of the sample having less spread than the population. And what this adjustment is meant to do is to bring up the sample variance and standard deviation to a higher number. It's meant to boost them up higher so that they're closer to what the variance and standard deviation equal for the entire population. So if we didn't do this adjustment and we calculated the variance and standard deviation the same way as we did over here, these values would come out even smaller, which would mean that they would be even further below the population values. So when you divide by one less, you're dividing by a smaller number. And when you divide by a smaller number, you get a bigger answer. And when this comes out to a bigger answer, then this also comes out to a bigger answer, which means that these two values are, by using this adjustment, these two values were brought up closer to what the population values equal. So they're not these two values right here aren't underestimating these values as much as they would be if we didn't use that adjustment. And the reason why there's no adjustment for the mean absolute deviation or the range is because no adjustment has been developed because these values are pretty much never used to measure spread. Really only the variance and standard deviation are used in actual research.